Hi, my name is David Leclerc. I'm with the Flow-Stammetry Lab here at the University of Chicago. I'd like to present the Avalon today. This is a two-part tutorial. In the first part, I just want to show what's in the box and how the software is designed. You can see that it's very intuitive, very easy to use. In the second part of the presentation, we'll actually sort some cells, so you'll see how the machine handles itself. The Avalon is quite easy to use. The startup, the QC, all of that is automated, so you don't need to worry about it all that much. So before we get started, if you want to follow along, you can use the quick start guide, which if you are on the instrument, you'll find in the front panel. For now, if you're at your computer, you can actually pick it up on the FlowLab server. It's under the training material folder. This instrument is equipped with the 100 micron tip, and the frequency of vibration is about 41,000 K, which means that we basically generates about 41,000 droplets per second. The implication here, and something that you need to keep in mind if you are planning to use this instrument, is that we are somewhat limited in the number of cells that we can sort per second. Typically, using a 70 micron tip will generate as much as 90,000 droplets per second. And so the idea is that if you are planning on using splenocytes or bone marrow cells, any of these samples where you usually have a concentration of 20-25 million cells per ml, if you try to run that on the Avalon, you'll see that the efficiency of sorting will be very low, and that's simply because there are just too many cells for the amount of droplets that we're able to generate. So if you are planning on sorting splenocytes or bone marrow, you're probably better off using another one of our instruments here on campus. The Avalon was tailored to sort cell lines expressing fluorescent proteins. There are basically two lasers in this box. The first one is the 48 nanometer laser. The second one is 561. So we can excite GFP, DS-Red, and Cherry, D tomato, as well as a handful of fluorophore markers, so FITC, P, Percy PSAT 5.5, PSAT 7, and so on. No APC, although you can excite it off the 561. The emission is not, the excitation is not as efficient as with a regular red laser, and no brilliant violet dyes. We don't have a violet laser on this machine. I can show you the filter configuration here. There are 6 detectors on this machine, 2 detectors for the scattered light of laser beam itself, so forward scatter is not on this figure, but it's there as well. And then the side scatter gives you another granularity. And then we have FL1, 2, 3, and 4 are generic names for our detectors. So what's really important here are the bandpass filters in front of each of these detectors. In front of FL1, we'll find 52530. So that's the bandpass filter that's typically used to sort or to pick up signals from GFP expression, FITC, and so on. FL2, we have the 58625. So this is proper for P emission. In front of FL3, we'll find 61525. So here we can use M-Cherry, DS-Red, D tomato. Under FL4, you'll find 655 long pass. So here, whatever is above 655 will be allowed to go through. So here we can use Percy PSAT 5.5 and PSAT 7. When you first log in on the instrument, you can go to Setup and Maintenance and get the instrument started. There are 2 steps. The first one, simply click on Startup. Basically, the instrument will do its own thing for about 20 minutes. When the startup is complete, then you'll be prompted to run the QC. Here, you will need what are called ProLine beads, which is basically a bottle of beads that you'll find in the fridge at the FlowLab. You can put 5 droplets of these beads in a 5 ml tube, stick it in the instrument, and then click OK. The instrument will then align the laser automatically and give you the best possible illumination for each passing event that will cross that laser beam. And then we'll also calculate the drop delay, which will ensure that you will get a very pure sort later on. Now once your QC is complete, then you're pretty much ready to run your sample. So we can go to the Home tab here, and I'll find all the tools I need to draw my graphs. I got histogram and density plots. I typically prefer density plots, so I can use that tool. Simply click on it, graph will show up. By default, I go to forward scatter area against side scatter area here. If I want to change that, I can do so by clicking on any of these icons here. I can change the scale. If I check log here, I'll use, for in this case, side scatter on log scale. The graphs I'll need to sort, I always start with the forward scatter area, side scatter area, and then I also need to discriminate for doublets or cell aggregates. In this case, we can use the forward scatter area against the side scatter, the forward scatter width. So the width basically measures the time of flight of the cell in the laser beam. So in this scale, all the cells should basically have the same width. All the cells should take the same amount of time to cross that laser beam. So all the cells that will be above that main cluster of cells that have the same width, I can assume that these will be doublets. And finally, we're going to run GFP expressed in cells. So I'm going to make one last graph. We're going to look at GFP. So I need to use the FL1 graph. I'll use it on log scale. And I'm going to look at it against my log parameter here. I'm going to go through the panel that controls the sample intake here. Basically have different buttons. The first one here will start and stop the acquisition of the actual sample. If you just want to have a look at how your cells look, you're going to use this icon. Later on, when you're ready to sort, you'll be clicking on this guy. This will start the actual sort of your cells and stop it as well. If you want to refresh the image, you can click on this icon here. If you just want to pause your sort or your acquisition, you can click on that pause button here. Here we have a ejection button. If you want to get your sample out of the instrument, you can click on that. There's also a button on the front panel of the instrument that you can use. It's going to do the same thing. Autosave here, we have a checkbox. Basically, whenever you stop the acquisition or the sort, all the cells that have been acquired, you can get the option of saving them automatically when you click on autosave. Basically, a big window will pop up and prompt you to give it a name, give a name to your sample. Below here, we have an icon. Basically, this guy is indicator of the pressure you're applying to your sample. You can see 3 different triangles. So as you click on this icon, you are increasing the pressure. So 1 triangle, 2 and 3 triangles are increasing the level of pressures. If you are not really confident in that system, you can actually type in a target event rate. So basically, if you want your sample to run at a constant 7,500 cells per second, you can type in that value, and then the instrument will regulate the pressure so that it keeps that target. There's a limit checkbox here, so if you want to automatically stop the acquisition after a set amount of cells, you can set a value here. So say you'd like to stop after 15,000. When I click on start the acquisition here, this software will automatically stop once I reach that limit. Cycle mode basically will refresh the image as I run my sample. If I don't click it, basically all the events will pile up on my graphs, and after a while it becomes hard to figure out what's going on. So cycle mode will basically refresh the image after 1 second or after whatever amount of seconds you want to keep the instrument, you want to keep your data on the graph. Interesting tools here. So you got sample agitation button. So basically no agitation, half agitation, and full agitation. So if you want to vortex your sample as it runs through the instrument, this is quite useful. 2 lights, so the one to look at your samples and one to look at your actual collection tube. Then you have a pressure control thing, so if you want to keep your cells at a specific temperature, you can type in the value here. You have shutters for both of our lasers. Obviously, you don't want to close the 48 nanometers. Typically that's what's going to give you your forward and side scatter, so you want to keep that open, but if you don't really need the 561, you can turn it off if you don't feel like having it around. There's a button here. This is fluidic system control. Basically, it's telling us how much liquid we have in our system. So we have about 9 hours of waste available, about 8 hours of DI water, and about 1 day of sheet fluid to run through. The interesting part here is that, well, obviously when you get started on the sort, you might want to empty out the waste and fill out the water and sheet. But if you run in a situation where the waste gets full as you are sorting, the instrument will allow you to change the tanks while sorting, so you don't have to stop. You simply need to click the swap bulk fluids, and then basically you have a set amount of time to sort your different samples. To change the tanks. Controls for the voltage of each of your detectors is down here. You can type in whatever value you want or use a slider bar to run through your samples. You have a threshold here triggered on whatever detector you decide. And then up here, once you've set all your voltage, you might want to draw regions around a subset of cells you're interested in. So you can use these icons to draw your gates. If you need to compensate, so let's say I'm actually looking at second marker here on FL2, I'll need to compensate my GFP will probably bleed into that second channel here, so I can use the compensate bar here, and I got a slider bar that showed up that's going to allow me to do my compensation. I can also auto-compensate or view the matrix. Once I'm done, I get the compensation matrix values are going to be over here. Once you're satisfied with the gate, so let's make a first gate here that we can assume will be, oops, let me change that here. Okay, so let's do gating. So let's assume that I'm gating around a cluster of cells. Here I can apply this first gate on the second graph simply by right-clicking on the graph, apply gate R1, and then I can make another gate R2. And this one I can apply the 2 gates on the last one by simply clicking again, and then I can select R2, R1. I'll make a final gate R3. Let's say we want to select R3. This is the population I want to sort. If I right click, I can decide where it's going to go, left sort or right sort. And when that is done, then I can go to sort logic. Sort logic will give me an option of what tubes I want to use. Let's use 5 ml tubes for now. Then I get to this window. Basically, I got on both the left and right side of the sorting chamber, I have space for 5 tubes. And basically I can tell the software where my collection tubes are. Whenever I decide on a enrichment mode, I'm basically telling the software that I have a collection tube in that location. Typically I'll use purity. Enrichment is if you don't really care about the purity of your sort. You can sort negative cells. You can ask us later on about that stuff. When you're ready to sort, I can click close window here, and then I can click on start and stop sort. So this is pretty much all there is to it. And once you're done with the sort, we can go back to setup and maintenance and do the shutdown, and then the instrument will basically do close up on its own. In the second part of this presentation, I'm actually going to sort a couple of cells, so we'll see how that goes.